All right, this video is about how to factor trinomials, and I feel like this is a method that not only teaches you the understanding of factoring, but also gives you a method you could use with any type of polynomial, or at least any type of trinomial. All right, so first we have to identify our a value, our b value, and our c value. So those are the coefficients in front of the x squared, the x, and then your constant at the end. Okay, now what I like to do is I like to start off by remembering that what we're trying to do when we're factoring here is we're trying to figure out what this is, what two things multiply together to give us this polynomial. So it's like the reverse of the distributive property. So you might have remembered doing distributive property in algebra, where you have something like, let's say, x plus 1, 3x minus 4, and you're trying to distribute. So x times 3x would be 3x squared, and x times negative 4 would be negative 4x. Then you come to this 1 and distribute it. So 1 times 3x is 3x, and 1 times negative 4 is negative 4. And so then what we end up doing is we have a 4-term polynomial, and then what you would have done is combine these like terms in the middle, and this would have been your polynomial. And what you want to do when you're factoring is you're trying to go from here to here. Okay, so notice that what we had first was something with 4 terms, but then those middle terms had like terms, so we were able to combine them. Okay, so thinking about what this looks like, what we want to do is undo this process. So I want to figure out what those middle terms are that allow me to add them to give me 6. Okay? Well, let's take a look at what we notice about our initial problem here. So we have a 3 and a 4, and we have a negative 4 and a 3. We know that negative 4 and 3 add to negative 1. What do 3 and negative 4 multiply to? Well, that would be negative 12. Okay? And so what we're trying to do is we're trying to find two numbers that multiply to the product of the first and last number, while at the same time add to the number in the middle. So what I do is I start thinking of number pairs that allow this to happen. So things that multiply to 12 and add to 1. Well, really it should be negative 12. Well, I could try 1 and 12. No go. 2 and 6. Nope. 3 and 4. Well, that's a possibility, but in order to have a negative product, one of these numbers must be negative. And we have to have a negative sum, so I need more negative than I did positive. So my 3 and my negative 4 are the numbers that I use here. And then what we would do is we would look to see what this group has in common and what this group has in common, and then we would factor. So it's that process that I'm going to take to do the problems that you see here. So let's start with that first problem. Okay? That first problem that I wrote down, I had started this process but then wanted to backtrack. So let me back up and do the steps again. So I need to figure out what multiplies to my a value times my c value. So 7 times negative 1, that would be negative 7. But they need to add to 6. So let's start making our list of things that multiply to negative 7. Well, if I do 1 and 7, oh, that looks good. But I need to have a negative product, so one of these numbers must be negative. And since the sum is positive, I need more positive than negative. So negative 1 and 7. Okay? So what I'm going to do is I'm going to rewrite this as negative 1x and positive 7x. And I'm going to bring down my first and last terms. Okay, now I have this as 4 terms, and what I need to do is I need to factor by grouping. The first group, if I look at 7x squared minus 1x, well, numerically 1 and 7 can only be divided by a 1. X squared and x, I could divide both of those by an x, so I'm going to factor out 1x. You don't have to put the 1. I divide these terms by 1x to see what's left over. So 7 divided by 1 is 7. X squared divided by x is x. And here, 1 divided by 1 is 1, minus 1. And x divided by x, well, those cancel out. Okay? Now, I'm going to go over to this next part, bring down my plus sign. When I look at my numbers 1 and 7, I can only divide them by a 1, but I don't have anything else in common. So when I divide these by 1, I get 7x minus 1. Okay? Now, looking at my groups, these two groups have the same exact quantity. So that means that that in itself is a GCF. So 7x minus 1 is a common factor. Once I use them, I like to cross it out so I know I've used it. And my remaining factor is 1x plus 1. Okay? A lot of times we don't write the coefficient of 1, so this is probably the best way to answer this. Okay? Now, if you wanted to check your answer, you could distribute back out. So 7x squared plus 7x minus 1x minus 1. And now combining my middle terms, 7x minus 1x is 6x. Okay, and now we end up with the exact same thing that we started with. Okay. Let me try another example. So here's example 2. For this one, my a value is 3, b is negative 10, c is 7. I'm looking for two numbers that multiply to 3 times 7, so 21, while adding to negative 10. So let's start thinking of things that multiply to 21. Looks like 7 and 3. Well, I know that that 7 and 3 will give me a 10, but how do I make that a negative 10? Well, if you have a negative sum here and a positive product, that means that both of those signs have to be the same. And since we can't add two negatives and get a positive, we're going to have negative numbers. So negative 7 and negative 3 are my numbers. So that is what I'm breaking this 10x down into. Alright, so now I'm just going to go ahead and factor this. Okay? Alright, factoring by grouping. The first group with the 3 and the 7, I can only divide by 1. X squared and x I could divide by x. We divide these by 1x, and we get 3x minus 7. I have a minus sign here, so I'm going to bring that down, and then I could divide these numbers by 1 again. We're really dividing by negative 1. So negative 3x divided by negative 1 is positive 3x. And 7 divided by negative 1 is negative 7. So, what do we notice here? Those are the same. So 3x, that's a weird looking 3. And we'll fix that. 3x minus 7 is one of our factors. 1x minus 1, or just x minus 1, is the other factor. Okay? Alright, we're going to look at one last problem. For this one, my a, b, and c. A times c is 60. Need my numbers to multiply to negative 16. So making my list of numbers. 1 and 60, nope. 2 and 30, nope. 3 and 20, getting closer. 4 and 15, nope. 5 and 12, closer. 6 and 10. That might be what I need to get to 16, but this is a negative, so make sure that these are negatives. Okay, so negative 10 and negative 6. It doesn't matter the order that you put those. The point is, that's what you rewrite this b value as. Bring down the first term and the last term. And now we're ready to factor by GCF. So I'm going to group the first two and the last two together. First two, the 3 and the 10, I can only divide by a 1. but both terms have an x in common. So we get 3x minus 10. I have a minus sign here, so I bring it down. Now 6 and 20 can be divided by 2. So I'm going to have 3x plus 10. Whoops, not plus 10. So I really factored out a negative 2. So, whoops, those should have been negatives. So it would be 3x minus 10. Okay, it's always a good check. Okay, so now looking at our factors, the 3x minus 10s are the same. So 3x minus 10 is a factor. 1x minus 2, or just simply x minus 2, is the other factor. And this is our factored form. All right.